Antiderivative of a vector valued function. If we have a vector valued function r of t equals the f of t, g of t, and as a third component h of t, then to find the antiderivative of the vector valued function r of t, we do it component wise, i.e. we integrate f of t, g of t, h of t dt, and this is equal to the vector that its first component is the integral of the first component of the vector valued function, and the second component is the integral of the second component of the vector valued function. Likewise, the third component is the integral of h of t dt. Consequently, if we are looking for the definite integral of the vector valued function, we do it again component wise. So if we are integrating from a to b of r of t dt, so we do it also component wise from a to b f of t dt, integral from a to b g of t dt, and then the integral of h of t from a to b dt, and we apply all rules that we know of definite integral, since f of t, g of t, h of t are scalar functions. Evaluate the given indefinite or definite integrals. So let's have some examples. If we are going to evaluate the integral of the vector valued function 3t minus 1 as a first component and second component is square root of t dt, then this integral is equal to the vector, and the first component is going to be the integral of 3t minus 1 dt, and the second component is the integral of t to the power half dt. Let's integrate. So now the integral of the first component is going to be 3t squared divided by 2 minus t plus constant c1, while the integral of the second component is going to be t to the power half plus 1, which is 3 over 2 divided by 3 over 2 plus constant c2. And this can be written as the vector with first component 3 over 2 t squared minus t. Second component is 2 over 3 t to the power 3 over 2 plus the constant vector c, where the constant vector c is the vector with c1 and c2 as its components. Problem number 2, evaluate the given integral. Integral of 3 over 2 squared 4 over t dt. Likewise, we are going to do this integral component wise. So this is equal to the integral of 3t to the power negative 2 dt, and here we have 4 divided by t dt. The integral of the first component is evaluated through the power rule of integration. So we have 3t to the power negative 1 divided by negative 1, and don't forget the constant of integration. However, for the second component we have 4, and the integral of 1 over t is ln absolute value of t plus the constant of integration. So we can write the result as negative 3 divided by t, and the second component is 4 ln absolute value of t plus the constant vector c, where the constant vector c is equal to c1 c2. Problem number 3, evaluate the definite integral from 1 to 4 of the vector valued function square root of t plus 3, and the second component is 5 times t plus 1 to the power negative 1 dt. We can rewrite the vector valued function and the integral as t plus 3 to the power half, and here we have 5 divided by t plus 1. How can we perform this integral? Well, we are going to evaluate this integral component wise. So we are integrating the first component with respect to t. So here we have t plus 3 to the power half dt, and the second component is 5 multiplied by the integral from 1 to 4 of 1 divided by t plus 1 dt. For the first component, we can evaluate this integral using the power rule of integration. So we have t plus 3 to the power 3 over 2 divided by 3 over 2. And here we don't have any constants since it is a definite integral, so we are going to substitute from 1 to 4. For the second integral, we have 5 ln absolute value of t plus 1. And here as well, we are going to substitute from 1 to 4. I would like to remind you here that I applied the power rule for the first component because we have the rule saying that if we are integrating some function which is raised to some power multiplied by its derivative, the derivative of the inner function, then this integral is equal to f to the power n plus 1 divided by n plus 1 plus constant. For the second component, we applied the rule that says if we have the integral of rational function with denominator as f of x and its numerator is the derivative of denominator, then this integral is equal to ln absolute value of f of x plus constant. All what we need to do now is to substitute. We are going to substitute by 4 minus substitution by 1. So here we have 3 over 2. Let's substitute by 4. So we have 3 plus 4, which is 7 to the power 3 over 2, minus substitution by 1. So we have 4 to the power 3 over 2. And for the second component, we have 5 multiplied by ln absolute value of 5 minus ln absolute value of 2. And since 2 and 5 are positive numbers, we don't need the absolute value bars here. So this is equal to the vector with 3 over 2. Here we have 7, 3 over 2. 4 to the power half is 2. And 2 cubed is going to be 8, right? And here we have 5 ln 5 minus ln 2, and this is the final answer. Problem number 4, evaluate the given definite integral from 0 to 2 of the vector valued function with first component as 4 divided by t plus 1, second component is e to the power t minus 2, and third component as t e to the power t dt. Now you know how we are going to evaluate this integral. Indeed, we are going to do it component-wise. So here we have the integral from 0 to 2 of, we can take this 4 outside, so we have 1 over t plus 1 dt. And the second component is the integral from 0 to 2 of e to the power t minus 2 dt. And finally, the third component is the integral from 0 to 2 t e to the power t dt. This is equal to 4, and the integral of 1 over t plus 1 is going to be ln absolute value of t plus 1. And don't forget that we are going to substitute from 0 to 2. Here for the second component, e to the power t minus 2, the integral of this function is equal to e to the power t minus 2 as well. And again, we are going to substitute from 0 to 2. Finally, so let's integrate t e to the power t by integration by parts. So if you take u as t and dv to be the function e to the power t dt, then differentiating u, you have dt. Integrating dv will produce that v equals e to the power t. Now, the integral of t e to the power t dt is equal to, apply the integration by parts formula. So we have u times v, which is t e to the power t, minus the integral of v du, which is e to the power t dt. And this is t e to the power t minus the integral of e to the power t is e to the power t, and don't forget the constant. So this can be written as e to the power t times t minus 1 plus constant. Consequently, the integral, the definite integral from 0 to 2 of t e to the power t is e to the power t times t minus 1, and don't forget that you are going to substitute. So let's do the substitution here. We substitute by 2 minus substitution by 0. So we have for the first component 4 times ln absolute value of 3 minus ln absolute value of 1. And for the second component, when you substitute by 2, so e to the power 0 is going to be 1 minus substitution by 0, which is going to be e to the power negative 2. Finally, for the third component, let's substitute t equals 2. So we have e squared. 2 minus 1 is going to be 1. Minus substitution by 0, e to the power 0 is 1. And here we have negative 1, so negative is going to be positive 1. You can write your final answer as 4 ln 3, since ln 1 is 0, so it is just only 4 ln 3. Second component is 1 minus 1 over e squared. And the third component is e squared plus 1. You are done. And the last problem with us for today is number 5. Evaluate the integral from 0 to 4 of the vector valued function 2t e to the power 4t. Second component is 4 divided by t squared plus 5t plus 6. And third component is 4t divided by t squared plus 1 dt. As we know, we are going to compute this integral component-wise. So let's integrate the first component. The integral of 2t e to the power 4t. How can we evaluate this integral? We are going to evaluate this integral using integration by parts technique. So let's take u equals t and dv equals e to the power 4t dt. Differentiate the function u, so you have du equals dt, and integrate dv to get the function v, which is going to be 1 over 4 e to the power 4t. Now, integration by parts technique will give you that the given integral equals u times v. So we have 1/4 t e to the power 4t minus the integral of v du. So we have 1/4 e to the power 4t dt. So we have 1 over 4 t e to the power 4t minus 1 over 16 e to the power 4t plus constant. How about the second component? Let's integrate the second component. The integral of 4 divided by t squared plus 5t plus 6 dt. How can we integrate this one? As you may notice here, we can factorize the denominator here. So we have 1 divided by here t, and 6 is nothing but 2 times 3. Both are positives. We have managed to factorize the denominator to 2 linear factors. So we are going to follow the technique of integration by partial fractions. So here we can rewrite this as 4 outside here multiplied by the integral of some constant divided by the first factor plus another constant b divided by the second factor dt. To find the values of a and b, we have 1 over t plus 3 times t plus 2 is equal to a divided by t plus 3 plus b divided by t plus 2. If we multiply both sides by the common denominator, we have that 1 equals a times t plus 2 plus b times t plus 3. This last equation is true for any values of t. So let's substitute t by negative 2. This will give you that the left hand side is going to be 1 and the right hand side is going to be b. Similarly, if we choose t to be negative 3, the left hand side is going to be 1 and the right hand side is going to be negative a. So these two equations gives you that a equals negative 1 and b equals 1. Consequently, The integral of the second component is equal to 4 multiplied by integral of -1 divided by t plus 3 dt plus integral of 1 divided by t plus 2 dt, and both are standard integrals. So this is going to be 4 ln absolute value of t plus 2 minus 4 times ln absolute value of t plus 3 plus constant. As for the third component, the integral of 4t divided by t squared plus 1 dt. Now, how can we evaluate this integral? You can evaluate this integral by substitution. If you take u equals t squared plus 1, then du equals 2t dt. Use this substitution into the integral. It will give you that the integral is equal to 2 divide u du, and this is nothing but 2 ln absolute value of u plus constant, which is 2 ln absolute value of t squared plus 1 plus constant. Now we can write the integral of the given vector valued function as, so the first component is here 1/4 t e to the power 4t minus 1 over 16 e to the power 4t. So here we have t e to the power 4t divided by 4 minus e to the power 4t divided by 16, and we are going to substitute from 0 to 4. The second component is equal to 4 times ln absolute value t plus 2 minus ln t plus 3, and we are going to substitute as well from 0 to 4. Finally, the third component is 2 ln t plus 1, and don't forget that you are going to substitute from 0 to 4. Let's do the substitution by 4 minus substitution by 0. So you end up with the first component is going to be 15 e to the power 16 plus 1 divided by 8, and the second component is 4 ln 6 over 7 minus ln 2/3, and the third component is going to be 2 ln 17.